Alright, so finally we're at the end. Welcome to the first presentation in this last module. This last module is going to focus primarily on the wide area networks and their evolution. So the idea here is that we're going to start back in the 80s with original point-to-point links and then work our way forward to modern times. So the problem with Ethernet is that it's not very good at long distances. Ethernet cabling is limited to 100 meters, and burying cables, especially Ethernet cabling, is costly and requires land privileges. In other words, you need to actually own the land in between where you're starting and wherever it is you want to, go to. High bandwidth between offices is usually not needed. In other words, you don't need an entire 100 MIPS at all times between your offices. You may only need 64 kbps at any given point. So the solution to this is leased lines. Leased lines use existing telco equipment to basically provide a simple data connection that's always on. The idea here is that you rent the circuit from the telephone company, they provide a switch circuit for you, and the circuit's on. It doesn't run at a very high bandwidth, but that's okay. Telco is responsible for intermediate connections, so you don't have to worry about trying to bury lines on other people's property. And the leased lines are much slower. We don't have to worry about that, at least for now. And if you do need a faster line, then you pay the telco more. Some telco terminology, there's what's called a channel service unit, data service unit. This takes a serial connection and converts it to bits on a leased line, on a two-pair line. Newer modules actually have this built in, but you need to know what a CSU-DSU is. There's what's called customer premises equipment. This is the equipment that's located on the customer's site, whether or not it belongs to the customer. There's what's called a demarcation point. This is the point at which the customer is no longer responsible for data or equipment. In other words, once it leaves, say, the modem, then that's it, you're done. And typically this is everything that's behind the CSU or DSU, all of the customer premises equipment that's in front of that. There's also what's called a data communications device, a DCE, and this is what's responsible for transferring the data across the leased line. And then there's what's called the DTE. This is the device that actually sends or receives the data, and this is typically an endpoint. So here are some different link speeds for leased line types. Over the top we have a DS0. This is the simplest possible type of leased line. Then we have a DS1, which is also known as a T1 here in the States, and that runs a bit faster. We have the T3, which runs faster still. And then we have the European equivalents, which are an E1 and an E3. I personally actually like the way that E1 and E3 are designed because they're in nice even powers of 2 as opposed to like the T1 and T3, which are some weird numbers, 24 and 28. Not entirely sure where they got that. And you'll notice that the bandwidth breakdown is a little bit different. And Japan actually has their own version of the E1, that is the Y1. It's basically the equivalent of an E1. So WAN data link encapsulation is a little bit different. You need to make sure that before we send out the data, we encapsulate it in some sort of layer 2 header, much like we did with Ethernet. So there's what's called HDLC, High Level Data Link Control. And HDLC is Cisco proprietary, but it contains just enough information to frame the data and send it out. It's a very low overhead encapsulation type, and it's what's preferred if you're running Cisco equipment at both sides. There's also what's called point-to-point protocol. This is not proprietary, so you can run it on non-Cisco devices, and it has a lot more features, but unfortunately it does have a lot more overhead as well. Now, link control protocol within point-to-point protocol has quite a few features that I feel like you guys need to know about for the CCNA. Does what's called looped links detection. In other words, it can detect if a telco or terminating in loops the line. And this is typically done when the line is down for maintenance or if a line has failed. The router will usually respond by shutting down the link if it recognizes and sees its own magic number on the line. It also does error detection. PPP has a frame checksum, and so what it does is it uses a link quality monitoring to keep track of the number of errors. If there are too many frame errors, then the link is taken down so that you can deal with the problem. Some more features, multi-link support. Normally you actually have to divide traffic over several links, and you would do that with a higher layer routing protocol, but multi-link PPP allows routers to treat a single group of point-to-point links as a single physical link. In other words, if you have multiple leased lines, you can treat them like a single line. PPP also supports authentication, and this is actually in use in DSL lines today. Since HDLC has no security features, typically the use for PPP is authentication, and it basically allows you to verify that the other side is the device that you want to connect to. You can do it with PAP, which is Password Authentication Protocol. I don't recommend that because PAP actually sends your passwords in clear text to be picked up by whoever happens to be listening on the other side. You can also do it using CHAP, which is actually way more secure and uses a hash instead of a direct clear text password. So to configure a WAN interface, typically the ones that we're going to configure are serial interfaces. In this example, we've specified encapsulation HDLC, and we've set the clock rate on this interface. Now, look, you may or may not need to set the clock rate on an interface, typically because the clock rate is set by whatever device is upstream. This is usually done by your telco to determine what the bandwidth is. You can also do PPP with encapsulation and authentication. So we have to specify a PPP username and password, and then we specify interface serial 0/1, encapsulation PPP triple P, and then triple P authentication. And all you have to do is create the username and password. You don't necessarily need to associate the username or password with anything. It will automatically go out and check those. Some other WAN technologies, digital subscriber line. Some of you may be familiar with DSL. This allows both data and voice to be sent on the same line using what's known as a DSL access multiplexer. The data component's always on, unlike most analog modems and kind of like leased lines, but normally the connection type is asymmetric. In other words, you're going to have a higher download speed than you are an upload speed, and for some businesses and consumers, that's fine. There's also what's called DOCSIS. This is probably what you're using if you're connected to Cox. This operates in a very similar manner to DSL. It uses channels and it multiplexes over basically between channels 3 and 4, and it's completely asymmetric. In other words, you're guaranteed a faster download speed than an upload speed, and there's no way to change that because of the way DOCSIS is set up. There's also what's called ATM. ATM is actually going out in favor of all Ethernet and all IP, but it's mostly used in enterprise or telco networks where you need to transmit multiple types of media, for example, data, voice, and video, all at, over the same network. ATM is perfect for that type of thing, and it supports higher transfer speeds than frame relay, which we'll talk about a little bit later. So to troubleshoot WAN connections, show interfaces as your friend, and there's a debug specifically for triple P that you can use to determine, all of that good triple P stuff. I hope you guys enjoyed the presentation. If you have questions or comments, put them below, and I'll see you in the next presentation.